Okay, today we're going to talk about linear programming. It's putting systems of equations together and finding the optimum solution, either the maximum or minimum. Um, or, so we have some things that we have to create: constraints, which is a system of inequalities that confine us to what we can and can't do with the situation. Objective function is what we use to either maximize or minimize those points that they cross. Keep in mind that these are real world situations, so we're going to live in quadrant one. Okay, the steps to solving linear programming is we're going to graph the system of inequalities, which is the constraints. We're going to find the corners, which means in that shaded region, all the corners that make the shape up where these lines cross. And then we're going to use those corners and plug it into the objective function to find either the max or the min. Okay, here's an example of one that is given to us, so all we really have to do is do the bottom part. But here we have the objective function, z is equal to 4x plus 2y. The constraints, which have already been graphed for us, are here written, and of course we would rewrite this into slope-intercept form to get them graphed, and then listing the corners. That's where we're going to start. So I can start over and I see I've got a corner here at 1, 4. I've got a corner here at 2, 1. And then I have a corner here at 4, 0. Because this side has no bound, this is called an unbounded region. Usually when it's unbounded, we are just finding the minimum because it goes on infinitely and there is no max to this problem. So we are not even going to find the minimum. So now what we do with this is we take our objective function and we plug these values in. So 4 times 1, because that's x, plus 2 times y is 4. So this is 4 plus 8, which is 12. Do it again. 4 times now the 2, because I'm working on this ordered pair, plus 2 times the 1, that's 8 plus 2, which is 10. And then the last corner would be 4 times 4 plus 2 times 0, which is 16 plus 0, which is 16. Well, I crossed out the wrong one, didn't I? We're going to only do the minimum. We aren't going to do the max because it's unbounded. And the minimum value between these three is 10. So the minimum value is 10 when x is 2 and y is 1. So that's the second part of what we're going to do when we do a full problem. Okay, so now I'm giving you some constraints. Notice I am just giving you quadrant 1. I see my objective function is up here already written for us. Now my constraint is x is greater than 1. So x is 1, so that line is here, and greater than is in that direction. Y is greater than or equal to 3. So I count up y at 3. And now that is in that direction. And then the last one, I've got to solve for y, and I get y is less than or equal to negative x plus 12. So we've talked about how to graph a slope-intercept form, so I'm going to count up to 12. And then I have a negative 1 slope. And less than is this direction. So my shaded region is all in here, because I went to the right of the pink, above the purple, and below the blue. Now my corners, I've got graphed, and there's a corner here, a corner here, and a corner here. So let's list them. So I've got 1, 3, 111, and 9, 3. Those are my corners. Now I'm going to plug this in of 4 times 1, plus 5 times 3, and this gives me 19. Now I've got 4 times 1 plus 5 times 11, and that's going to give me 59. And then 4 times 9 plus 5 times 3, and that's going to give me 51. So the minimum value, the smallest value, is at 19, and that's when x is 1 and y is 3. That makes sense. It's the farthest down and left. The maximum is 59, and that's when x is 1 and y is 11. Now that's the top. That's the highest it is, but it's not the farthest right. So sometimes you got to make sure you're careful and do the math right, depending on the objective function. Okay, so now on these, we're just going to practice writing the constraints. Okay, that's what we're going to practice doing, because sometimes that's the hardest thing to come up with. Mr. Bloom is designing a rectangular garden with a fence around it. A fence around is implying perimeter. It's rectangular, so perimeter is 2 lengths plus 2 widths equals that perimeter. He can use no more than 80 feet of fencing. Okay, so 80, no more than, so 80 is the largest it can be. So it's telling me to use x and y, so 2x plus 2y, and 80 is the biggest, so the perimeter has to be 80 or less. Then the next one is he wants the width to be at least 5 feet, so the width is x and 5, and the least means that's the smallest I want it to be. And then the length to be at least 20 feet, length is y, and that's 20, at least 20 feet, so it can also be larger than 20 feet. And there's my constraints. Okay, now we have a full-out problem to do, and this is what I'm going to ask you to do. You're going to do some of the other fill-in, but you will have one of these on your exam. A surf shop makes and sells surfboards and wakeboards and wants to figure out how many to sell each to maximize the profit. First, I'm going to define the variables. So the two things we're talking about are surfboards and wakeboards. So I'm going to make, wrong pen. I'm going to make x equal the number of surfboards and y equal the number of wakeboards. Write the constraints. So here we go. I've broken it down for you. An owner can make at least 3 surfboards, okay, and at least 6 wakeboards, but no more than 37 total boards. So there are 3 constraints. So surfboards are x, so x, the smallest amount is going to be 3, so it's the smallest amount. Wakeboards is 6, and again, 6 is the smallest amount, so I can make more. But I can make no more than 37 total boards. So surfboards plus wakeboards and the 37 is the largest I can be, so adding them together is 37 or less. Now the next portion is writing our objective function, And it says a surf shop makes a profit of $150 for each surfboard and $100 for each wakeboard they sell. So profit is $150 for each surfboard and $100 for each wakeboard. So now I've got it all set up. Now I'm just going to have to graph it. So I'm going to graph x has got to be greater than or equal to 3. I'm going to have to make this bigger so I can see it. Greater than is to the right. And then the next one is greater than or equal to 6. And that's going to go up. And then this equation, I've got to solve for y. So y is less than or equal to negative x plus 37. 37's up here. And now I'm going to go and graph this carefully to find all my corners. Yes, you can hear me click, click, click. But notice I'm going down 1 over 1 to get every point. So now here are my corners. And since that's less than, my shaded region is in here. Now I'm going to put this back down so I can see it. Okay, so now I'm going to list my corners because I've graphed them. I've got 3, 6, 334, and 31, 6. Notice that they aren't going to be above the 37. Now, I'm sorry, those were the corners. I put them in the wrong place. Now I'm just going to go plug it into my objective function. So I'm going to plug in 150 times 3 plus 100 times 6, and that's 1,050. And then 150 times 3 plus 100 times 34, that's 3,850. And then 150 times 31 plus 100 times 6, that's 5,250. The maximum they should make and what will be the profit. So obviously the largest number is this one. So he's going to make 31 surfboards, 6 wakeboards, and the profit is going to be $5,250. And that is an entire problem. So that's our first day of linear programming. You'll practice some of this, and then we'll do another day of practicing.